Hi guys. Well, this is the other radio I wanted to show you, and again, the main reason I'm working had this out. I had restored this, at least the amplifier and the power supply, several years ago. But the main reason I got it out is because I want to use the power supply on the Radiola, RCA Radiola 20. I think I can use that for the B+. This radio we're going to talk about quite a bit because it's unique, and we'll get to that here in a minute. I thought I'd let you hear it.
You'll love the Commando Tab tablet. Get it for just $159.99. This is a limited time offer. Order your Commando Tab tablet today at shop.commando.com.
It was built in 1928, and it uses a
we're about to post a message online.
A high impedance speaker. This is out of the cabinet. The speaker cabinet needs to be redone.
As long as you've typed anything into your Facebook page, whether you decide to post the message or you simply erase it and post nothing, the text entered on the page is still sent to Facebook's network service and saved. There's nothing in Facebook's rules that prohibit this. In fact, the rules are quite ambiguous.
They vibrate a little bit when they're out of the cabinet. It's supposed to be screwed here and here in the cabinet and held down. These have a permanent magnet and then a high resistance, a lot of winding coil built into them, and they use a reed that fits up inside. I don't know if you can see that, but it goes inside the coil, and that's what's moving, and then it's attached to the speaker.
With its grand opening on May 23rd, longtime supporters, Van and Bonnie, have been invited to privately. Brought to you by the USDA, HHS, and the Ad Council.
Who do I perform for? I perform for all the awesome composers whose music deserves to be heard.
Picks up the strong stations really good. It's a local station. And that's in our station. It's about 100 miles away. So anyway, shut this down. The radio, the cabinet needs a lot of work. There is a cabinet that goes to it. First of all, there's a front that's metal, and as you will see is in pretty sad shape. I mean, the metal's alright, but the paint is virtually rusted away. What's left is just right along the edge where there's some wood that covered it. This had, you know, supposed to look like, painted to look like wood, and this would slide down inside here, and then the volume control hook here, your tuner knob goes through here, and then the power switch hook here. These would slide out, leaving these two knobs hooked up, or the switch and the volume control hooked up, because they come unscrewed from the power pack. I'll show you that in a minute. And this slid down in, and then there was a piece on top that holds it in place. A piece of wood, a slot right here, and this is just screwed down. It's not glued, screws held it in place so you could work on it. You slide that out, you take the top off, and in order to get the radio out, to dismantle this, this section, and this section, all three are separate and bolt down separately. And in order to get them out, especially these two, there's a pin that, and I'll show you here in a little bit, that goes from the tuner to the amplifier section. You cannot slide these far enough to get that pin out, so the cabinet has to be removed, and it's held in place with 4 screws, and you know, it basically comes off the top just like this. So you slide it off, and it just comes right off, and then now you can take it, get inside and take it apart. Now there's a piece that goes on top of here, and a piece of aluminum, which is this. It's a Spartan radio, Sprarks Withington, and model 69, which is on the top. The top is the worst shape. The back side's fine for the most part. It's got some dust on it, but it's got some loss and finish. And then of course you got the label here, model 69 Spartan. But the other side is pretty sad. Back here. So as you can see, it's got some pretty good veneer loss, but beyond that, it's got a good warpage to it too. So I may have to make up a complete top unless I can get this thing to straighten out. It's separate solid boards and separately put together, so they were glued together right here and right here. I don't know, once I get the veneer back off of it, which ain't much holding it, it's possible I might be able to wet it or steam it and get it to flatten out. I'm not sure. Otherwise I'll just have to build one. Now, some interesting facts about this particular model, or this particular radio. This guy, you know, the cabinet and the unit back here, which basically is got the transformer and all the power supply components, filter caps and chokes and everything in it. It's got an 80 rectifier. And then on this side's the audio output tube. So it's the power supply and audio output, and is where the speaker hooks in the back. This is for a model 69. But this and this is for a model 931, which is not a big deal because the amplifiers, there was just slight differences throughout the several different models, very minor differences, and I'll show them on the schematic, but they were all interchangeable. They used the same wiring connections. They basically, if I can get you kind of moved over here, kind of zoom in on that. They use the same wiring connections here, same number of wires coming from the amp. The selector or tuner on this side, pretty much the same with a couple minor differences between models, but pretty much the same. The only major thing that had a lot of differences in was the power supply and audio amp. This is the lesser of all of them. It runs 180 rectifier, and it's supposed to have a basically a 250 audio output tube, or type 50. I think there was a card-on number, which is Sprarks Withington's tube numbering, tubes that they actually produced. I believe it was either 586 or 686. I can't remember now. But the 250 is identical. But this is the lesser. This one only pumped 220 volts plate to the type 50. So this was using the 69, 79A, and 89. Now the model 89A had virtually what appeared to be basically the same thing, except it used two, I believe there were 81 rectifiers or half-wave rectifiers, two of them, to make a full wave. And they used the Type 50 output tube, but it ran it at full voltage, which is around like 450 volts on its plate. And then there was others that they had. There was one model, and I don't remember which model, I think the 103. I may be wrong on that number, but they had two Type 50s output tubes. And then there were several other models that used the 182s, a pair of those, and I think a couple other tubes. So the major differences was more or less in here, although the connections and the power going to the amplifier was still the same in all of those. So you could mix match whatever you wanted. It was not a big deal because all your connections could be hooked up. The other nice thing about this, it does have multiple voltage taps, a switch that you can run from 100 volts input from the AC line. It's 100, 110, 110, 120, or 120 and 130. So you can run, whatever you have on your outlet, you could switch to and get your full voltage. I'm running between the 120 and 130 tap because I generally run around 125. Other things about it. Okay, for one thing I did change. When I first got the radio, about, I don't know, 10 years ago, it did not have the output tube in it. So what I did, I was too cheap at the time to buy a Type 50, which at that time was like, you could get a new old stock Globe style for around $60. ST style for about $45. And I thought that was high. And so I just, for some reason, had it in my brain that they would come down in price, and which was really dumb, because they didn't. They range now upwards of $300 a tube for new old stock Globes, and STs upwards of $200 a tube. So they're ungodly. I should have bought one way back then. What I got in here is a 45. Now, the Type 50 uses a 7.5 volt filament, and it is a directly heated cathode, and so is the 45. And what you end up, I'll bring the schematic up here. You got 7.5 volt, and you got a tap coming off the center, and that goes up and comes to a resistor, which then goes to ground. This is a cathode resistor for biasing, and then of course this goes out to the speaker, the negative side of the speaker, and then the positive. The Type 45 is a 2.5 volt tube, so I had to drop 5 volts. Well, it turns out that was kind of fairly easy. I had to pick up a couple of resistors, 5 watt resistors, at 1.67 volts, or 1.67 ohms, to put in each line. Now you want to put one resistor and one resistor in each line, equal value, to keep this circuit balanced. If you do not, if you put like one resistor, like the double of that, which is like 3.3 ohms, only on one side, then it's not balanced anymore, and it'll get a hum. You got to keep these two balanced with the center tap basically going to ground to keep your hum out. So I had to have two 1 2 1 2/3 ohms resistors. They're about 4 watts, so what they drop. So I put 5 watt resistors in there, and I was able to come up with those. And that dropped the 5 volts off and gave me a 2.5 volt here. Now as far as the rest of it goes, since this is a low powered one where it's 220 volt plate, that's perfectly fine for the 45. The load resistance here, the high resistance speaker, which runs about 8,000 ohms impedance, is perfectly fine for the 45, and the amount of negative bias I need for the tube is the same as what the 50 would be running in here, so the bias resistor stayed the same. And so the only thing I really had to do was just put those resistors in the filament lines and then just plug the 45 in. If you got one that is a higher voltage output, around 450 volt plate, that's really way more than what a 45 should handle. You can put a 6L6 in, you know, more modern tube in, and you can make an adapter for it. Basically, you're just gonna the screen and grid and the plate are tied together, so that you just, you know, you turn a pentode or beam power tube into a triode, and then you do have to put a resistance in to reduce the filament, because those are 6.3 volts and it's still 7.5 volt filament feed. You have to do little minor changes on that filament lead, but other than putting the resistance in there so you can get the biasing circuit hooked up, because they're indirectly heated. But you can run a 6L6, which will handle the higher plate voltage. And there's a guy on the internet, but I can't remember what his website is. I've got it saved somewhere, but I can't right now off the top of my head find it. He makes an adapter, which you can make your own, but he makes an adapter to adapt from the 4-pin to the 8-pin octal socket for the 6L6. And in that adapter, everything is set up so that you just plug it in and it's like 20 bucks. So that's one change I changed. I don't know, I'll try to show you some of the changes. These schematics are rather kind of small. The 931 uses dual 82s, output tubes in push-pull, so their power supply was a little different. But here's the model 69 right here, and here's your tuner selector section, which is this unit here, and then your amplifier and detectors right here, which is this part. And some of the changes between the 931 and this one. Okay, in the selector unit, let's see if I can get these side by side here and get them up where you can see them. There we go. On the 931, the antenna comes in and taps in the center tap on this primary coil. Over here, it comes down and comes right in the top. And then these two coils are attached to another coil that goes to ground here, whereas in this, that coil doesn't exist. What they did to actually create it was they put a tap off of this coil, which would be this one here, on the side here, and brought that down to ground. Other than that, they're exactly the same selector unit. Now, in the this unit here, the amplifier unit, on the schematic, there's not like a huge differences. They're drawn a little differently, but one of the biggest differences is this capacitor right here. Could be or could not be on this unit. They actually can put it in the 931 as a permanent fixture. Otherwise, it is very similar. They did a little changing on one of the coils down here, and that it doesn't show up really on the schematic so much as it is on the unit itself. When you look at it, they just basically moved a coil and to the top, and did a little minor change there. Otherwise, they're basically the same unit. And again, the 931 power supply's got dual 182s and a little bit different power supply as opposed to the 69, 79A and 89 power supply unit. But otherwise, it's got the same connections here. That's those connections there. Now, I'm going to go ahead and shut off the camera at this point, pause it, and get this thing pulled apart. And I want to show you some details a little more, and kind of go into the circuitry, because this is not a TRF radio. By definition of tuned radio frequency radio, they're tuned amplifier radio frequency. In other words, each tuning section, each condenser section coil combination has an amplifier. This does not. This selector has no amplifiers whatsoever. It's just got 4 caps, 4 condensers, and 4 sets of coils, and all its job is, it does not amplify, it just tunes. Once it's get the tune, it feeds it into this tube here, and this is your amplifier. There's 5 stages of amplification, untuned by this. It just feeds the signal to them, and then they amplify it, send it to the detector. These were 484s originally. There was a replacement tube for them that came out a year later. That was the 485. The only difference between the 484 and the 485 card-on tube is the fact that the 485 heats up faster. It'll heat up faster. The 484 takes about 35 seconds, a new one, to heat up and get operating, and the 485 does it in less than 20 seconds. They're triode tube, they're virtually identical to the Type 27 tube. So anyway, I'll go ahead and pull this thing apart, and you can get a little closer look at stuff. I'll be right back. Alright guys, I'm back. Here's the amplifier. I pulled it out of the cabinet. The main wires come through here, the light hook's here, and then it just fits down in there. There's 4 screws on the inside and then 2 on the outside. This bolts down to the cabinet, and let me see if I can move around there if I don't make you sick. Okay, it would bolt in these slots here, down just like so, but you only have so much room to move it, and the tuner fits here and stays solid, and it has this long rod that goes through, and that's how it makes connection into the amplifier right at this point here. So that would come through this hole right here. And if you had the cabinet in place, even if you lift these up, you can't pull them. It hits the cabinet. You cannot. You'd have to lift them gently and together, but you still can't get them completely pulled apart to get it apart. So that's why the cabinet was designed to dismantle the way it is. And then of course these bolt down in here. The radio does. Grounds to this the main frame right here. I've added some solder. That is the ground point, which is right here. Grounds to the power supply underneath it, and then it's just a piece of sheet brass that's silver plated, and then the tuner, or selector unit, metal piece, will fit there and ground. Now here's your selector. Basically standard double cable, rotational type unit. Copper plates for the tuning condenser. Underneath here is the coils. They're shielded somewhat from each other. Underneath here there are, what you get from the top here is a way to fine tune each section, the last 3 sections, and then this one fine tunes that very first section, so that you can get them all tracking the same. Now, I said that this was not a TRF radio because there is no amplification in this. All the amplification is done right here, 5 tubes of amplification, but they're not tuned. Tuned in the way that, you know, I've got some sort of tuning condenser that I'm rotating or something else that is tuning them. They accept whatever frequency the selector picks up, and then they amplify that. Well, that's fine and dandy, except one of the big problems with any of these older tubes back in the day and stuff is that you know, you might get it to really work really good at, say, the low end of the broadcast band, but when you get up there to the high end, it started losing gain off. Well, there was a guy named Lester Jones that came up with this design that is in the Spartan, and there's 3 or 4 other companies also used it back in the late 20s. But for one thing, to use his patent and his patents on this, he was pretty reasonable, whereas RCA was quite high. RCA came out with the Super Heterodyne design the late 1929 is when they patented it, and this is not Super Heterodyne either. What Lester Jones came up with was a way to keep the circuit balanced over a wide range of frequencies in the broadcast band without any feedback. It'd keep them neutralized so they wouldn't feed back, and that was a total different type of design, because even the TRF design was actually patented, and RCA actually owned that too. And it turned out that Lester would do, well, he charged Spartan $50,000 a year. I mean, that's it. No individual royalties of like 7 or 8% per radio or anything like that. Just one lump sum, $50,000 for a year of using my patents. And so that was a heck of a lot cheaper. So it's called a Technidyne, or at least that's the name he gave it. Now I'm going to bring you down here because I want you to look at a better schematic that I got on the computer, and we'll bring it down here where I can get you lined up on it. We'll zoom in. Maybe a little bit more. There we go. The biggest thing I want you to notice on the schematic is how they draw these coils. And I don't know if you can really see it too well, but there's a wire coming here that wraps around, and then there's a wire coming up here that wraps around. These two are side by side, and they tried to draw that in the schematic. And then it gets to this point and reverses and goes up like this, and then one wire goes off to the grid, the other one feeds to the plate. All these coils are similar in that. Now this is the only one that doesn't switch. We'll get to that in a minute. The rest of them all switch direction part way through the coils, and then this one here at the end ends up making a switch 4 times. These are what is known as extremely tightly coupled coils. And we'll go back to the radio now and look at that. And I'll try not to make you too darn sick. Yeah, right. That worked. Let's back off a little bit here. Maybe all the way, and I can just lift the thing out. Alright. That last coil that I showed you, that had the 4 different directions, is this guy right here. There's 2 coils right here, 2 coils here, 2 coils here, and 2 coils here. I mean, it's all the same coils, but they're switching direction as they go into each one. So, but they're laid right over top of each other. Extremely tight coupling by doing that. So you wind one winding and you wind the other winding right directly on top of it, and you get a real tight coupling that way. Each section is where they're switching directions in the winding. One of the very first coils is right here. Since it was only 2 section, it's located here. And then the rest of them are underneath. Some of the others, like here and here. And this is that one that doesn't change direction at all. And then there's some chokes involved in here. These guys here, and here are all 4 capacitors. 3 of them are decoupling for the cathode circuit. So in other words, they just come from the cathode to ground, and the other one is a decoupling, one single decoupling cap that goes from the plate circuit to ground, the plate feed. And they're in there just to keep RF and stuff like that from affecting the power supply, or getting back in the power supply and then getting some feedback. That's why they're there. Now, so why is this thing working? Because if I tune in a radio station, say if I could pick up a station, I had a nearby station or a station I can pick up at around 600, and it comes in good, it sounds good, it's working good, and I got plenty of volume. Maybe it's a fairly close station or a powerful one, and then I tune on up the dial and I get to, say, around, I don't know, 1400, 1500, and I pick up a station there. How is it that this amplifier can accept either one of those and not really lose gain? Well, the reason it is because of those coils and the capacitance of the tubes. Now, he expressly wanted a particular design of tubes, which is fine with Spartan because they were making their own tubes. And the main thing what he wanted was a tube that the internal capacitance inside the tube would stay stable with heat and with frequency and voltage. So that cathode to grid and grid to plate and cathode to plate capacitance you find in the tube manuals would stay exactly what it says, no matter how long the tube's been on, how hot it gets, what voltage I apply to it, what frequency I apply to it. That capacitance stays the same. Some tubes, especially the older tubes, it didn't. It would kind of fluctuate a little bit and float on you. As the elements heated up, they'd expand and contract. You'd get movements. And so what they did was they tightly coupled the plates, which was one of the main issues, but also the rest of the circuitry, to a lot of uprights to keep them tightly coupled in the globe tubes so that they wouldn't expand so much. But that was one of his requirements, because he was going to make use of that capacitance in the circuit. Now, showing another schematic which doesn't show the individual windings very well. A lot of times they drew them just like this. If you notice, on these coils that are basically, they're basically tuning and coupling. They're mostly a coupling and tuning circuitry that is, you're not tuning it, but you got to be able to couple. except for this first one with one cap here, everything else has no real capacitors. Now there's a couple capacitors on this, but that's just a decoupling bleed off filter for the filament winding, the heater windings. These tubes are indirectly heated cathodes, by the way. But and other than the filter caps for the detector, this is just a simple pi filter that bleeds off RF, so that you just get pure audio coming out and feeding up to the output tube. There's no other capacitance in here, so what he was making use of is both the coil capacitance as well as what little bit of circuit capacitance in the wiring, and mainly the tube capacitance. Now, the unique thing about this is whatever frequency you feed into these coils, made the way they are by reversing the windings, would actually, and since this one doesn't show up very well, the other schematic does, but this winding and this winding are not the same number of turns. They're considerably different number of turns. What that would do on these guys would allow them to actually auto-tune. As you feed a frequency in here, the reactance and the impedance would change on these, and you'd have changes that happen with the coils, impedance and everything, and what that would do is change the reaction of the coils to each other, where they switched, and you had a different number of windings that was going the opposite direction. That purpose of switching it, and that dealt with the counter EMF and counter magnetic fields that would be produced, and by changing the impedance, which is directly coupled to frequency, then you could actually make the darn thing tune, self-tune to the frequency. It would actually search and look for the best circuit resonance for the signal to feed through the amplifier and give the maximum amplification. He ended up getting pretty much less than 3 dB drop from an extremely low frequency around 100 hertz, which is way below, I mean that's in the audio, all the way up to well over 10,000 hertz, and he stayed fairly flat in his testing by doing this. This one here is a simple coupling, although it still works the same way. This is more just here for neutralization, to keep the amplifier staying in tune, basically, as far as neutralization goes. And then we go back to switching them. And we get down here going to our detector. It worked out that in order for this thing to feed the detector, since it's running a tremendously different plate voltage and it's a plate detector, he had to end up doing the windings, 4 switches in the windings, and then even a choke that had a double switch on it to get a good signal path going in, a good signal strength. It's an ingenious thing, and I haven't even really touched on exactly how it works, but that's an extremely long video to go in depth on how this circuitry works. But the other thing I want to point out is in this tuning section, or the selector section, it shows as though these are transformers. They're individual coils, mounted individually, but they are loosely coupled. This coil is loosely coupled to this one, and this one's loosely coupled to this one. The whole reason for that is to get a very broadband response. The looser your coupling, the wider your bandpass is. And you can get a pretty much a good flat top broadband tune in here, whatever frequency you're tuned. It is a tad bit more than it should be, and they did do some later work on that, made some minor changes later on this, but what it does give you is good fidelity, because you're getting both side bands, you get feeding through. And with these being tight coupled, it is a pretty sharp, whatever frequency this is tuned to, whatever goes in here, it is pretty sharp peak that these will tune out to and work out when they resonate to go into resonance. They will be a real tight peak because they're tightly coiled, very narrow bandpass. So it can be relatively selective. Now the bad thing about it, with all these impedances and also the fact that these triode tubes are not super amplifiers by any means, they're RF amps and very low level audio amps. They're like a few, in an audio type circuit, they're a few hundred milliwatts. They're really low. And even with 5 amplifiers, it really likes to have a really long antenna to get as maximum strength of signal coming in. The fact that you're feeding through all this circuitry before you even go to an amplifier also requires that. So when one of these radios operated, about 200 or 300 feet of wire antenna would be recommended, or even longer. Let's see, what else can I say on it? Not a whole lot else. It wasn't long. Like I said, this radio was built in 28. They built several models during the 28 and early 29. By late 1929 and into 30, an agreement with a lot of manufacturers due to a lawsuit and a Supreme Court ruling about patents and stuff was brought about between RCA and a lot of radio manufacturers, both for TRF and Super Heterodyne, which reduced how much they could charge percentage-wise per radio, and that brought it down to a level that a lot of companies decided to start going with either the TRF or the brand new Super Heterodyne. Now, I believe Sprarks Withington waited at least another year just to see how well the Super Heterodyne works out. But in any case, by 1930 they had quit using this circuit, which ended up, they had a contract with Lester Jones through 1930, and they had signed a contract for, after 1928, they signed a 2-year contract, 29 and 1930, for $100,000, and only paid him about like $20,000. So he ended up, and they refused to pay beyond that. So he ended up having to sue him, and he did win. He got his money. But Lester went on into a lot of other inventions. He is actually the inventor of the dog bone style wire wound resistor. Ceramic tube, wind wire onto it, and then have 2 leads coming off clamped on there. He actually owns that invention, and that was never challenged. He continued to use it until it ran out 25 years later. But so, and along with a lot of other things, he did inventions on several other devices in radio. There was a couple speaker inventions that he had, and several other things. The man did all right for the most part, but by the time the patents were running out, the poor guy did spend quite a bit of his money too, and wasted a lot of it. So he died a pauper, unfortunately. But brilliant man to come up with a circuit like this, and it does work good. And it allowed for several radio companies not to have to pay a large sum. I mean, it doesn't sound like much, 7 or 8% per radio, but if that's per radio, and that a lot of companies back at this period of time, 7 or 8% may have been all their profit margin. That might have been it. So if they have to turn around and pay that they basically don't have no profit at all, and so it was kind of hard on a lot of companies. So he did give them something that at least for a short period of time allowed them to stand on their own 2 feet and still make the profit. So anyway, I think that's about it on this. I'll get to work on figuring out what I want to do with this as far as making a power supply out of it, at least temporarily for that radiola. I got a few other things to do to it, and we'll see if we can get it working, hopefully. So I got some comments I need to answer yet, and I will get to you guys. I've been sick the last 3 days. Starting to get a little bit over it, but there's some sort of crud going around here that causes a real bad sore throat, and you just don't feel very good. So anyway, I'll see you guys on the next video, and I thank you in advance for all your comments and your support, and we'll see you on the next video.